Welcome back to this intro to GeoPandas. In this video, we'll be querying PostGIS and getting data from it into GeoPandas. So we can start by importing GeoPandas and importing the create engine function from SQL Alchemy. We'll then use create engine to create a connection to PostGIS that we can pass into GeoPandas. So we need to start with a query string. This is just standard SQL language. So just as a first pass, we can select everything from our flights and just limit it to 100. So now that we've got a query string, we can say geopandas.geodataframe.from PostGIS. And this function belongs to the geodataframe class itself and not to the root geopandas, which is something that I often forget. So you pass it the query. In this case, it's a really basic query. Give it the engine so it knows how to connect to PostGIS. And then the last thing that is pretty critical is specifying the geometry column. If you don't do that and your data comes back with an unexpected geometry column, you're going to get an error. So we can capture that output. And we've got the data as we put it into the database, including our geometry column back as a geometry type. So maybe we can grab just one of these flights out of here. So build up a new query. And then we can pretty much just copy this line from up here. And if we use that explore function, we can see all the data that we've got about that one flight. That one's not super compelling. Let's see if we've got a different one. Also not the best, but you get the idea. Okay, so we can start to build out more complex queries. So we can try to merge the two data sets that we put in there, the airport laydown and the flights themselves. So maybe something interesting could be to buffer out the airports a little bit, find airplanes that are flying over them, so taking a few things into account. So let's start with that first one. And if we go back and take a look at the airport data itself, we've got obviously a coordinate as a geometry. It's got a different geometry name because that's how OGR to OGR inserted it. We've got an altitude for that airport, but it looks like it's in, it says character varying, so it's actually not as an integer. I guess in this case, Ogre to Ogre miscategorized that column. So we'll have to take that into account when making our query. So let's make this airports query. So let's cast that altitude as an integer. And then all of the PostGIS functions start with st. So we've got st transform. And so in order to buffer this out, our data is in 4326. So we're going to push it to a meters-based coordinate system, buffer it out by meters. In this case, let's say like 2 kilometers. And then we'll have to push it back to 4326. So we're actually going to have a bunch of nested queries here. We're going to have st transform. We're going to have a buffer, and then st transform inside that. So this first one, we're going to push the geometry to 3857. That's our geometry call. All right, so now we've got meters. So we can say buffer it out 2 kilometers. And then now we've got our buffer. And so we can push it back into 4326. So this is basically just making 3 calls inside of each other. A single transform, a buffer, and then a transform back. And then we need the rest of our query. We'll call this geometry, then we need to specify where it's pulling it from. So we can run that, and just to sort of see what this looks like, we can make that from PostGIS call. Ah, wrong query name. Cool, so now all these airports are no longer points, but they're buffered 2-kilometer polygons. In this case, that might not even have been quite enough, but it's good enough for now, I think. So we can do a nested query here, merging this new query that we've made with the flights information. And this is where I think using Python to build out these queries is super powerful, because you can use f strings to build this one ahead of time and then insert it into a greater query. And this, as you can see, these queries can get kind of long, so I like using triple quotes so we can have multi-line strings. So we can alias that first one. Use f strings to bring that whole query up above down here. I'll leave the select open from now. So we'll say flights as A, our airports buffered as B. Now we can say, just give me everything from flights. We only want those flights where there's an ST intersects. And the altitude's greater than the sum of the altitude of the airport plus, let's say, another 40,000 feet. So what I like about this query is it combines a few things. We're using information between 2 tables. We're also using things like altitude that in a standard spatial query would sort of, be an after filter. So that's our query. And I'm just gonna steal this from above. Change this back to query. And I timed this earlier, and I think it took about 8 or 9 seconds to run. So we're basically running an intersection on 41 million rows. So now if we zoom in, this is just plotting the flights that are flying above. So we don't have the buffer around the airports, but we can see this information. So now we could go back, and if we were interested in learning more about these flights, either individual ones or in aggregate, we could query PostGIS to get that information back. And just a note here, the way this query is constructed, we are able to take advantage of the flight's geometry index. We have lost the geometry index from the airports, but because we're kind of hitting these one at a time, I think that doesn't matter as much. So we're taking each of these geometries individually and taking advantage of the flight's geometry index. And because these airports are discrete, meaning there's no overlap between them, at least I wouldn't expect there to be any, these intersect calls are done by row pair. So if one flight intersected, or if a single airplane point intersected two airports, we'd actually get that point twice, I believe. So that's important to know, especially as you start to get more complex data. But in this case, I think this query works out really well. We're able to take advantage of the speed bump from the index, um, and we're able to get our results pretty quickly. 9 seconds is pretty good to run an intersect on 41 million rows. Now that we've covered getting data into PostGIS with GeoPandas and Ogre to Ogre, and querying data using GeoPandas with SQL queries, in the next video I'd like to cover the concept of Object Relational Mapping, or ORM, which allows us to insert and query this data while treating it as a Python object. There's a library, GeoAlchemy, which extends the SQL Alchemy library to allow for geospatial storage and querying. I hope you've enjoyed this video. If so, please consider liking and subscribing, and feel free to comment with any questions or requests.